once the data has been tabulated, the next step in research is to analyze the data. For analyzing the data, both descriptive statistics and inferential statistics can be used. In this part, we'll understand the descriptive statistical techniques that can be used to analyze the data. As the term indicates, descriptive means which describe, summarizes, or interpret the data set collected for a particular research study. Descriptive statistics include measures in general, measures of central tendency, measures of variability, normal probability curve, and linear correlation. Certain measures in general include ranking the data, preparing frequency distributions or cumulative frequency distributions, and representing data through graphs. Measures of central tendency refer to all those measures which are concerned with calculating the average or the typical performance of the sample selected for this study, and these include mean, median, and mode. Measures of variability refer to the spread of scores or the scatteredness of scores. And here we are concerned with how much difference is there among the scores of various units or elements in the sample, and one can calculate range, quartile deviation, and standard deviation. And then we have normal probability curve and linear correlation. Ranking simply refers to ranking the data set on the basis of certain criteria. Now, for example, if you have 10 students for whom you have collected the data and you have their scores on the achievement test, so the student who has achieved the highest score is given rank 1, and a student who has got the lowest score in the class is assigned a rank of 10. So you can rank the people on number of variables, maybe on the basis of height, on the basis of weight, on the basis of their performance, on the basis of teaching effectiveness, and so on. One can prepare frequency distribution, and that would require the calculation of a range, deciding the number of class intervals and the size of class interval, and then trying to determine the frequency which fall in each class interval. So you can prepare a frequency distribution, and then you can transform this frequency distribution into a graphical representation. You can also group the collected data according to certain theme. For example, a teacher interested in finding out the problems faced by him in the classroom, and maybe one of the problem is the low level of motivation of students, lack of previous knowledge with students, poor infrastructure in class, non-availability of internet facility in the class, then you can work out how many teachers actually point out to this problem which is faced by them in the classroom situation. You can also think of converting your data set into graphical representation, which can include preparing histograms, frequency polygons, or graphs which may include line graph, bar graph, area graph, or pie graph. Now here you can have a look at what is the difference between the histogram and the frequency polygon. Histogram assumes that the scores in a particular class interval are spread evenly in the class interval, whereas the frequency polygon assumes that the midpoint of the class interval represents the scores in a best manner. So this is the difference when we go in for drawing histogram or a frequency polygon. One can draw a column diagram or a bar diagram to represent the data. For example, if you are interested in what are the characteristics of the sample selected for a study and you have included male, female with varied years of experience or age, then you can think of converting the data into a bar diagram. Or if you're interested in finding out the technology used for communication split by gender, and you have the various technologies which can be used by male and female, then you can think of converting the data and represent it by the bar diagram. If you are interested in the change which takes place in one variable over a period of time, or you want to see how different samples have shown change over a period of time, or you are interested in finding out the sales of 3 different products and you want to see what has been the change in the sales of 3 products, maybe you can draw line diagram which provides you a comparative picture among the sales of 3 different products over a period of time. If, as a teacher, you are interested in finding out how many students in the class have attained different grades, maybe you have A, B, C, D, E grade, so you can have the pie chart which can provide you a synoptic view of the distribution of the students among the various grades which you have classified. Measures of central tendency, as I said earlier, represent the average or the typical performance of the group and can include mean, median, and mode. And when I say mean, median, and mode, mean is the measure of central tendency which has greater stability, and when scores are symmetrically distributed around the central point, we can calculate the mean of the group. When there are extreme scores, then mean is not the measure because it is going to be affected by the extreme scores present in the distribution of scores. Median represents the midpoint in the distribution. That means 50% of the cases lie above and 50% of the cases lie below the mean, the midpoint. And when exact midpoint of the distribution is needed and there are extreme scores which are present in the distribution, then median is the more reliable measure of central tendency. Mode represents the most frequently occurring score in any distribution, and it is a quick and approximate estimate of central tendency. Measures of variability include range, quartile deviation, and standard deviation. Range simply represents the difference between the highest and the lowest score. And when data are too scant or scattered, then range is the measure of variability. Quartile deviation is calculated when the measure of central tendency is the median and there is concentration around the median and there are extreme scores present in the score distribution. Standard deviation is the most reliable measure of variability, and even if there are extreme deviations present in the data set, they are taken into account, and mean and standard deviation are the two measures which are further used in further analysis of the data if the researcher is interested in t-test, z-test, ANOVA, or ANCOVA, mean and standard deviation are required. Linear correlation is also part of descriptive statistics, and the purpose is that we try to establish the degree of association between the two variables. So when your purpose is to determine the relationship between two variables which are available on the interval scale, then Pearson product movement correlations can be worked out. In the next part of the program, we'll try to understand the normal probability curve.